This is a flip video about redox reactions. So redox is just an abbreviated word, and if we look here, what redox really is short for is the word reduction and oxidation. Together, we can abbreviate them as redox. And we're talking about redox reactions. So far we've learned 5 different types of reactions: synthesis, decomposition, combustion, single replacement, double replacement. And sometimes these 5 reactions can also be classified as redox reactions. So specifically, we're going to be looking at synthesis and decomposition today. All synthesis reactions can all be classified as redox reactions as well, and some decomposition reactions can be classified as redox reactions. So what is a redox reaction? Well, let's first talk about what the word reduction means and oxidation. So in chemistry, the word reduction means to gain electrons, and oxidation means to lose electrons. So if you notice here, I have my little electrons being lost and they're being gained on this side. Oxidation reduction happens hand in hand. So let's remember that as we kind of proceed. Okay. So something else that's important to know or to write down is today when we talk about redox, we're really talking about the overall transfer of electrons that's happening in our reaction, how electrons transfer. But the thing is that in our balanced equations, we've never really seen electrons in the actual equation. So what we're doing is we're kind of breaking it down and looking deep within to see what's happening with our electrons. All right. In order to do this, we have this nifty little acronym. Okay? And that is, remember we said, if we go back, right? Reduction is gaining electrons. You have to know that basic vocabulary word. And so I've got here gaining electrons, reduction. Oxidation, we said, is losing electrons. And on this side, I have lose electrons, oxidation. And so we come up with this funny little saying, and that's Leo the lion goes grr. And who do we have here? Well, hello, everybody. I'm Leo the lion, and I go grr. All right. Thank you, Leo. Leo the lion goes grr. And so if you can remember Leo, grr, then you'll always remember that the definition of oxidation means to lose electrons. And the definition of reduction means to gain electrons. So let's remember that goofy little saying. All right. Now, if we take a look at a reaction seen here, as I said in the beginning of the video, we're going to be looking at synthesis and decomposition. Okay? And this is a synthesis reaction. A and B come together to make AB, right? We synthesize sodium chloride. All right, so if you notice here, we've got elemental sodium and elemental chlorine. And what that means is these are just atoms of sodium and atoms of chlorine. And they come together and make NaCl. Okay, well, what do I have to remember? Let's write this down. Is that Na, right, is composed of atoms and it's neutral. It's just the sodium that we see on the periodic table, solid sodium. Okay. And Cl is also an element, and it's composed of atoms as well, right? And it's neutral, no charge, no charge. Now, when these two come together to form NaCl, NaCl, on the other hand, we know is an ionic compound. And ionic compounds are made up of ions. What are the ions? Well, you should know this, right? So far, everything here is a review. We've got Na has a charge of plus and Cl has a charge of minus, right? So some things to also remember are when you are a plus charge, you're a cation. That meant you lost electrons. When you're a negative, that means you're an anion and that you gained electrons. Okay, if you noticed, when Leo came into the picture, we brought back terms like losing and gaining. and electrons. So really what we're learning here is kind of old stuff with a new twist. Okay, so now that you remember that, let's start with how to determine our oxidation reduction. You're going to be asked the following two questions, and that is, which reaction here, right, is oxidizing, and which one is reducing? In other words, they want to know which component is doing the reducing, gaining electrons, and which one is oxidizing, losing the electrons. So I'm just trying to point out some things that I already know. Okay, so as we said earlier, elemental sodium is composed of neutral atoms. So neutral has a charge of 0. So over any single element, I'm going to put 0. And if I look on the other side, what happens to sodium? We know that sodium becomes plus. So to go from 0 to plus, what had to happen? Well, I also know that plus means that I lost electrons. Okay, so this sodium had to lose electrons to turn into this. So losing electrons, remember what Leo said? Leo the lion goes grr. Lose electron is known as oxidation. So the oxidizing component is sodium with a 0, neutral sodium, right, being turned into sodium plus. We've got neutral, put a little 0 there so you know, turning into plus, sodium plus. Which then means that chlorine must be the reducing component. Well, let's see. Remember, chlorine also starts off as 0, right, neutral. And chloride, I know from the periodic table, is -1. So there's my minus. To go from 0 to minus, to turn into an anion, we know, we just said, to turn into an anion, you had to gain electrons. So chlorine is the one who's gaining electrons. So it turned from the beginning, which is neutral chlorine, to chlorine negative, right? And in order for this to happen, we had to gain electrons. And gaining electrons, right, according to Leo the lion, goes grrr, gain, grrr. Gain electrons is reduction. Reduction, so let's write that here. Gain electrons, reduction. Lose electrons, oxidizing. This is Leo, lose electron, oxidizing. This is grrr, gain electrons, reducing. Okay, and again, how did I know? All metals turn into cations, and all nonmetals turn into anions. So when I have a synthesis reaction, all of my metals will turn into cations, so they'll all lose electrons. Therefore, Leo, lose electrons, they're all going to be the oxidizing part. And that's true, opposite is true for the chlorine, right? All nonmetals turn into anions. I knew this from before. And so therefore they all gain electrons, right? To turn into a negative ion, that meant you gained. And so gain is grr. So we found our pattern. All right, let's try another one and see if this pattern holds true. Here we go. We've got cesium, that's an element. Remember, we said all the elements are neutral. Fluorine, which is an element, neutral. But now I have an ionic compound. An ionic compound are made up of ions. So I look up cesium on my periodic table, and I see that cesium is a charge of +1. And I look up fluorine, or in this case it's fluoride, and I know that fluoride is -1. Okay, now that I kind of know what ions they turn into, I have to then figure out which component is being oxidized and which one's being reduced. So is cesium being oxidized or cesium being reduced? Well, remember, if I'm going from 0, cesium 0, to cesium +1, seen here, I know that positive means, well, remember, positive means I lost. right? If I turn into a cation, that meant I lost electrons. Lost electrons. That's Leo, lose electrons, oxidation. Oxidation. Which means the other one must be reduction. They go hand in hand. One of them can be oxidation and the other one then must be reduction. So fluorine must be reduced, and it is. Fluorine starts off with a 0 charge, and it's going to F 1 minus. What's happening here? I turned into an anion, which meant I gained electron, which is grr. Gain electron reduction. Grr. Gain electron reduction. So fluorine is being reduced. Okay? All right, so it turns out it's true. Metals are oxidized, nonmetals are reduced in a synthesis reaction. Now, how about the reverse? How about in a decomposition reaction? Well, remember, not all decomposition reactions are oxidation reduction. We have to be careful. We want to stick to ones that have ionic compounds in them. And so I notice I have an ionic compound, right? A metal and a nonmetal. And that metal and a nonmetal are decomposing into my elements. So the same thing is true. I find my single standing free elements and I say these elements are 0, 0. They're neutral. Whereas when an ionic compound was formed, these are formed from ions. So Mg was 2 plus and Cl was 1 minus. This we know. Okay, so now I have to think about it. If Mg goes to 0, if Mg, which had a charge of plus 2, goes to 0, in order for Mg to go to 0, it has to do what? Well, to begin with, Mg2 plus meant that it lost 2 electrons. I want to put it back to neutral magnesium. Well, then I have to regain my electrons that I lost back on. So to go from 2 plus to regular neutral, put back the electrons you lost. Gain them, right? Gain those electrons that you lost. And gaining is grr, right? Gain. So now I see that magnesium plus 2 to turn into magnesium neutral is being reduced. Grr, gain electrons. Okay? How about chlorine? Well, in order for chlorine minus 1 to go back into a 0, so chlorine minus 1 to go back into chlorine with neutral, well, let's think about it. Minus 1 meant I gained or lost. Well, it meant I gained electrons to begin with. So how do I go to 0? I better lose those electrons to go back. So whatever you gained, get rid of it, lose it. And losing is known as Leo, lose electrons, oxidation. So I picked oxidation for this one. So it's just the reverse of what's happening, just the reverse. So in a decomposition of an ionic compound, my nonmetal is being oxidized and my metal is being reduced. It is the reverse. Say goodbye, Leo. Bye-bye.